Hello, my name's Alice Nisbet. I'm a PhD student working at the Quadram Institute in Gemma Languages Group. Thank you so much for checking out my poster, and I'll just give you a quick run through of what I'm currently working on. So enteric fever is a disease highly prevalent in lower middle income countries with 14.3 million cases being seen every year, leading to over 100,000 deaths. There are multiple causative agents of enteric fever. The dominant causative agent is Salmonella typhi, and that majority of research. I work on the second most dominant causative agent, Salmonella Paratyphi A, which is often overlooked due to the prevalence of Salmonella typhi. Specifically, I look at a phenomenon known as carriage, which is where after infection, the bacteria persist within a patient for an extended period of time, which can be bad for the patient as it increases the risk of gallbladder carcinoma, and is also bad for the patient's immediate contacts who are at risk of being infected with the bacteria themselves. So one of the things I've been looking at is the metabolic differences between isolates of Salmonella Paratyphi A from the same patients, and how those metabolic changes may change over time. So in a human-restricted bacterium, such as Salmonella Paratyphi A, it's historically been seen that isolates will reduce their metabolic capacity the longer they're in a patient, as they no longer need access to a wide variety of metabolic systems. However, when we looked at our chronic carriers, so these are patients who have harbored the bacteria for over 12 months, we actually saw that between their initial isolate and their most recent isolate, an increase in metabolic capacity was seen. And when we found in one of our patients a middle isolate between those two, it actually showed higher metabolic capacity than both the initial and the most recent, suggesting perhaps that the bacteria undergo an initial increase in metabolic capacity, which then slowly decreases over time. So we wanted to look for a genetic cause for this, which involved looking over 31 different carrier patients, all of whom had harbored Salmonella Paratyphi A for different periods of time, and looking to see what single nucleotide polymorphisms and small genetic differences we could see developing within these patients. And in over 60% of carriers, there was a mutation in either one or both of two genes. These genes were FNR, a fumarate nitrate reductional transcriptional regulator, and ADHE, a bifunctional acetaldehyde-CoA alcohol dehydrogenase. And indeed, both these mutations were present in the chronic carriers that we'd looked at. So in the initial isolates, there was the consensus sequence for both genes, and in the most recent isolates, both genes had developed at least one SNP, suggesting that these two genes may be responsible for that change in metabolic capacity. Interestingly, for the middle isolate in one of the patients, that only possessed SNPs in FNR, suggesting perhaps that the changes in FNR increase the metabolic capacity the most, and then when the ADHE mutation comes in, it slowly comes back down to a more stable level. To then further expand on this, we then looked in temporary carriers of Salmonella Paratyphi A. So these are patients who have harbored the bacteria for more than 3 months, but less than 12 months. And quite unexpectedly, the exact opposite pattern was seen, in of that the initial isolates showed higher metabolic capacity than the later isolates, suggesting that's dropping the longer they're spending in the patient. And when we looked at these mutations that we'd previously identified in the temporary carriers, neither of these carriers showed mutations in FNR, and only one of them showed a mutation in ADHE, suggesting perhaps that these mutations are not having the effect we thought in temporary carriers. So what we've identified potentially is a difference in metabolic capacity that can be used to define chronic carriers from temporary carriers. And perhaps that over time, as I said earlier, you've got that initial burst of mutations, which then slowly decreases and may slowly decrease to below the initial isolate's level of metabolic capacity, meaning it's closer to clearance of the bacteria, which would make sense as in the chronic carriers, this would remain higher as they're still persisting, whereas in the temporary carriers, this has dropped lower than the initial isolate due to them almost being cleared from the system. However, of course, a lot more further work is needed to look into this, but it may help us define the actual carrier states of Salmonella Paratyphi A and better help us understand how we can treat them and help the patients who are living with this currently not curable condition in many cases. So thank you so much for listening and have a lovely day.